Tools such as bench planes, chisels and spoke shaves will not perform their functions properly unless they are correctly maintained. This means regular inspection of cutting blades for gapping, rounded or out of square edges, or overly long sharpening bevels created by repeated sharpening. All of these indicate that regrinding is required. Producing good cutting blades on these tools is a two-stage process involving grinding, which is the coarse removal of metal to produce the correct profile of the blade and an even bevel, and sharpening or honing of the blade to produce a keen edge that slices rather than tears the wood fibres as cuts are made. Generally, 20 to 25 degrees is suitable for grinding wood cutting blades. An additional 5 degrees is a good angle to sharpen a blade to a keen cutting edge. In practice, it is often difficult to establish the required angle to the grinding wheel. A handy guide for a 25-degree angle is to have a grinding bevel about twice as long as the thickness of the blade. For a 20-degree angle, about 2.5 times the blade thickness is the length of the bevel. Nowadays, grinding is most commonly done on electrically powered high-speed bench grinders. These grinders have a coarse grinding wheel of about 36 grit at one end and a finer wheel of about 80 grit on the other. The wheels are made of abrasive grains bonded or glued together. Aluminium oxide of 60 to 80 grit is suitable for grinding tool steel. Silicon carbide of a similar grit can also be used. A correctly ground blade will be ground at right angles to the edge. Have a grinding angle of about 25 degrees to the face. Show only one continuous bevel, not multiple bevels. Retain its temper by not being overheated during grinding. Grinding at right angles to the edge can only be done on a wheel that is trued up. Some grinding can cause uneven wear, and some materials clog the wheel surface. These wheels can be trued with a wheel dresser or a silicon carbide dressing wheel or stick. The dresser or stick is moved from side to side across the tool rest of the grinder in contact with the grinding wheel to produce a straight face. The tool rest should be adjusted to a maximum clearance of about 3 mm from the trued wheel before blade grinding starts. Because of the high speed of electric grinders, it's easy to overheat blades during grinding. A change in surface colour of the blade to a light straw colour indicates early stages of overheating. If grinding continues, the change to a blue-black finish indicates metal which will not hold a keen edge. A container of water should be kept near the machine and the blade cooled frequently during grinding. Slower speed grinders use a constant supply of water to the stone. This avoids the problem of the blade overheating. There are common features and techniques to the grinding and sharpening of all blades. However, it's worth considering bench plane cutting irons separately, as the shape of the cutting edge is determined by the application of the particular plane. German jack planes are intended to remove large amounts of waste quickly. To achieve this, the cutting iron is shaped with a semi-elliptical or cambered edge when viewed face on. This produces a series of hollow cuts. In the case of the jack plane, there is less camber in the blade and the hollows are not as pronounced. The smoothing plane removes these corrugations. It is also used to flush off joints and to remove cutter marks from machine-dressed timber. A trying or jointing plane would be more suitable for truing up longer lengths of timber. To perform their tasks, the cutting irons of smoothing and trying planes are ground and sharpened perfectly straight across. The corners of the cutting edge are rounded off slightly to prevent them digging in and leaving small ridges on the dressed timber. The tool rest is set parallel to the face of the wheel, and for safety with as small a clearance as possible. Initial grinding may be needed to remove gaps from the blade or to return the cutting edge to square. The blade is placed on the tool rest and moved from side to side in light contact with the wheel. Holding the forefinger of the controlling hand under the blade and firmly against the edge of the tool rest helps guide the blade during these sideways movements. The steel is cooled regularly. The minimum amount of metal is ground off to remove gaps and produce a straight and square edge, or for a jack plane, a slightly cambered edge. If the tool rest is able to be adjusted, it is set to the correct grinding angle using a previously ground blade. If the rest cannot be correctly angled, the blade must be firmly grasped and held with the forefinger against the edge of the rest. With the cutting edge in contact with the wheel, the length of blade above the finger establishes the grinding angle. To achieve an even bevel, this angle cannot be changed during grinding. Adjustable tool rests, which maintain a constant grinding angle, are available to fit most grinders. With the blade correctly positioned on the rest, it is ground at this angle by moving it from side to side until the thick edge is almost completely removed. The blade edge is inspected from time to time by holding it up to the light to see if any thick edge still needs to be removed. The grinder is only used to shape the blade and is not used to produce the final cutting edge. For smoothing and trying planes, the blade is tilted sideways and the sharp corners taken off with just a slight touch to the wheel. During all grinding procedures, it is important to observe safety practices regarding protective wheel guards being in place, correct tool rest clearance, and positioning of clear safety shields. Personal protective equipment should also be worn. The grinding of chisel blades is more straightforward. The blade is ground straight across at right angles to the edge of the chisel to produce one continuous bevel. Spokeshade blades are small and difficult to hold during grinding. By fitting the blade into a slotted handle, the procedure becomes safer and the blade easier to control. The grinding angle of all blades can be varied depending on the intended use of the tool or the type of timber being worked. A firmer chisel, for instance, could be ground and sharpened at a slightly lesser angle to give an extremely sharp and efficient edge. A mortise chisel would probably be ground at a greater angle to prevent the cutting edge breaking away while chopping and leavering. The sharpening procedure is essentially the same for all blades. A wide variety of stones is available to produce a sharp cutting edge. These range from wet stones used with water to oil stones to diamond stones, which can be used with water or oil. Oil stones may be either natural abrasive stones, such as Washita and Arkansas, which are quarried and cut to shape, or artificial stones, such as aluminium oxide or silicon carbide. These are made of abrasive particles bonded together, with some composite stones having both a fine and a coarse side. A superior type of manufactured stone uses diamond grit. This is bonded to a stainless steel or resin base. Because of the hard diamond cutting agent, these stones retain their level surface even after prolonged use. As the word oil stone suggests, some lubrication is needed to reduce friction. More importantly, however, the oil floats off waste particles of steel to prevent the pores of the stone clogging. Traditionally, neat's foot oil was used. A better choice is a mixture of equal parts of motor oil and kerosene, or even kerosene on its own. For effective sharpening, the surface of the stone must be flat. With the stone lubricated, the grinding bevel is placed flat on the face of the stone. A slight rocking of the blade will indicate when it is flat. The 20 to 25 degrees grinding bevel is raised about 5 degrees to bring the blade to the correct sharpening angle. The blade is rubbed with gentle pressure backwards and forwards over the stone. It is essential to maintain a constant sharpening angle between the blade and the stone. Sharpening with a rocking action must be avoided. A honing guide is useful in controlling the sharpening angle. The blade is clamped firmly in the guide at the correct sharpening angle. The guide and the blade are moved together to and fro along the stone on a roller fixed at the base of the guide. To ensure even wear of the stone, the blade is moved over the entire length and width of the surface. Different books recommend different sharpening patterns or techniques. These can be a simple backwards and forward stroke, a circular motion, or a figure-8 action. To limit any rocking motion, a useful technique is to hold the blade side on. The overriding consideration, however, is to ensure that wear is spread evenly over the entire surface of the stone to maintain it as a flat and effective sharpening tool. The corners of cutting irons from smoothing and trying planes are rounded on the oil stone. Once again, a slotted handle provides a solution for small blades. As sharpening proceeds, a burr or wire edge is produced on the back of the blade. This is removed by turning the blade over and holding the back of the blade perfectly flat and firmly onto the stone. It is essential that no angle or bevel is introduced to the flat back of the blade. It may be necessary to turn the blade over a couple of times to remove the burr with a few final strokes. Traditionally, any remaining fine burr was removed by stropping the blade on the palm of the hand. A safer method is to draw it through the corner of some scrap timber. New blades often have surface grinding marks. These can produce a serrated cutting edge. The ultimate cutting edge can only be produced when the back of the blade is honed to a polished finish. Correctly sharpened tools not only make the job easier, but are a source of personal satisfaction.